So how can we then better understand the architecture? So in terms of layer perspective, we have seen before in the OSI for communication. And in terms of internet, here I would like to also share with you the different layer perspective. And looking at the first pointer over here, in terms of triggering of an event when there's a new location, right, and you have a new task to work on, there will be a lot of decisions to be made. How can you then decide whether you want to have more traffic lights or to reduce the intersections and so on? Should you have a flyover and etc. Right? So information can give you some understanding as I talk about traffic jams and so on. Even if you have all the control and all the intelligence, if the infrastructure doesn't facilitate, there's no way to clear the jam unless you have other forms of highway bypass and so on. So if you look at the IoT architecture in terms of layer, the first layer would be where we are today. I mean, in our course, we are looking at embedded system. We are talking about building out devices, sensory systems, and so on, right? So your MKR would be within here, looking at building up smart things. But your smart things, or in this case, MKR, would then need to get connected to the internet. That connectivity layer refers to your Wi-Fi, your Bluetooth, or some other near-field communication. And gateways is just a term to describe that device or the gadget that helps with the interconnectivity. So gateway can refer to your Wi-Fi router at home. Gateway can refer to the Wi-Fi device that supports your handphone or your laptop connection in the school also. Okay, so gateway is just a term to describe that device to support interconnectivity. Next, we have the data layer. So this data means a couple of things. It refers to storage, all right, your data lake. It can refer to how you store your data. It can refer to how you process and analyze your data, bringing out information through the chart, through analysis to provide intelligence and so on. All right, so these are the activities within the data layer. And then finally, in terms of application, all right, in terms of application, what do you want this data to do, right? In terms of control, what is that you want your application to achieve? So back to the smart home example, your TV and the curtain, right? Your application could be ambient control or a theater settings that you have as one of your applications. So when you trigger this application, automatically your curtain will know to close it up, your lighting will know to dim down, and then finally your TV will know that it's supposed to roll the movie that comes along. All right, but how would the application know that these are the few things that it need to do? The middle layer would have all this connectivity, the processors, information, and so on. How would your data then get to your devices? Through the gateway, the commands, and so on. It will then propagate down to your smart things, where your curtain, your light, and also your TV will be able to be shown, will be able to receive all those information. Okay. All right, so back to the smart things that I have talked about. This is where your MKR is located. All right, at the root of IoT are smart things. So this is the considered the bottom layer. In the earlier presentation, this would be the extreme left. It is considered the endpoint devices that bridge between the real and digital world. So when Prof. Howard shared with you about embedded system, the control, when embedded system sense the real world through sensors, all right? So this is the part where the devices is closest to the real world. And there are a couple of things as part of your project work. Some of you might be provided or selecting sensors as part of your integration. And what are sensors? They collect physical parameters and then they convert into digital signal, in this case, electrical signal, so that your microcontroller will know. A good example would be our XY MD02, which provide temperature and humidity sensing. We have actuators. So some of you might be selecting actuators from your lab kit. This involve a buzzer to provide sound and alarm. Some of you may be selecting the RC servo motor. It's a small actuator that allows you to use it like a lock because it has an angle or lever that you can manipulate that can serve as a lock, can be served as a linear actuators to push things around and so on. And of course, in robotic arm, they use motors to move the arms to achieve the movement. If you put some of these things together, all right, then you can form machines and devices. And this is where, when we talk about Internet of Things, the different facets and the different components coming to achieve one common goal. Next, in terms of our connectivity layer, just now I've tried to describe to you within the connectivity layer, we have the gateway. And in this layer, it really talk about how the networking is achieved, how things are joined together, be it wired or wirelessly. And the end goal is to join the internet. So the gateway appears to be here, which I've described to you in the earlier slides. Your different devices, gadget, your Arduino, MKI, and so on, can then join to the gateway. So gateway can be represented by different communication methods. So NFC, Bluetooth, Wi-Fi that you are very familiar with, LP1, low power, wide area network like ZigBee that I talk about in the use of your smart home application. All right. When we are, once we pass through the gateway, then what happens next when we go into the internet? All right, these are then using TCP or IP stack, which is the internet protocol. And I've described to you about the gateway earlier on, that it helps to perform the translation between different protocol, right? So gateway will use TCP IP talking to the server, but when it is trying to talk to your devices, it can either be any one of these. So therefore, there are ZigBee gateway, there are Bluetooth gateway, and so on. So the name itself, the first name, for example, ZigBee gateway, it means that the ZigBee gateway will facilitate communication with all the ZigBee devices around your home. But the other end of the gateway will be TCP IP to the internet. That is why if it's a wired ZigBee gateway, you will have your RJ45, which is the LAN Ethernet cable to be connected to your gateway. Or if it's wireless, the gateway will be communicating to your Wi-Fi router and so on. In terms of connectivity, there are many more different protocols or mode that you can be in. Wi-Fi that we are all familiar with, we have 4G. But you can see that this chart is to describe to you in y-axis, the amount of data, or in this case, speed of transfer versus the distance that you can transfer. So as we move up in terms of the y-axis, we can see that Wi-Fi is one of the highest data rate, how fast or how much data you can send within 1 second, followed by 4G and so on. 5G is not in this picture. 5G, of course, will be higher, and they promises even streaming of HD or 8K video on the flight. But I want to draw attention that as we move down, right, you can see that ZigBee is residing over here. ZigBee, Z-Wave, these are all for home automation. They are not particularly very high data rate because most of the data that we are sending are sensory data. Week 6, you learn about ThinkSpeak, all right? Sensor data need not be updated so quickly, especially when you look at environmental monitoring. Temperature of a room, humidity of the room, they don't change in milliseconds, neither do they change in minutes. Sometimes they change in tens of minutes, right? It takes that long to evolve or to change in those parameters. Therefore, they are considered low power, right? At the lower end, Sigfox, these are for long-range communication. Although they are low data rate, you can see that they can span, of course, I think what you are seeing here is in logarithmic scale. Here could be about 20 kilometers, right, for Sigfox. But in actual devices or communication using Sigfox or some other low power, long range RF, they promise up to 5 or 7 kilometers, right? And these are typically used in agriculture, right? For those who are familiar with RF, these are the technology used in those bigger areas in farms, and they require line of sight so that they can actually send data over. And if you look at some of these things, I think you should be able to understand that there are tons of options for you when you are choosing the connectivity layer. Okay, in the previous slides, I'm only showing you a small handful, but now you will see almost close to complete options to be selected. So outdoor, for example, outdoor, you might not have Wi-Fi. All right, what can you do? You have to make use of a 4G router. And these are cases where we were discussing when we talk about share a bike. So for the share a bike, or for the bicycle to know or communicating with their company server, then if it's really necessary, you will be putting in a 4G module within your equipment. just like the genset, the generator that is operating in construction yard, there might not be a Wi-Fi network available. And if you want to monitor your genset generator status, what you could do is to include the 4G module so that your genset can use the 4G module through our standard satellite and get connected to the internet. So in terms of choice, although you are pampered with so many different options, it is important for you to take note of these few items. All right, this is important, and I want you to pay attention to as I describe. Firstly, you don't want to overkill with range. And on the right, I have described to you that very often data rate, which means your speed of data transfer, is often inversely proportional to distance. Okay, so if you look at situation where you need distance, Sigfox would be the one that you will be using as compared to 4G because Sigfox is cheaper. And if you can accept the low data rate, then Sigfox will be your option. However, if your application requires tons of data, then you have no choice but to choose 4G LTE because 4G LTE supports higher data rate and giving you the distance. All right. So these are the things that you can look at. But if it's an indoor application, then you will see that Wi-Fi would be one of the best choice. But Wi-Fi has limited range. And in this case, I think this Wi-Fi, if it's able to support up to 800-900 meters, these are very special Wi-Fi. So at home, some of you might have already been encountering, right? If your home is slightly larger, you'll find that certain corner, your device may not have a very good Wi-Fi reception, and there you will have to add repeaters and so on. So in terms of range, what I'm trying to describe to you is that you have to be careful, right? Don't be greedy. If your application is needing an ultra short range, right here, the ultra short range would be could be Bluetooth, could be infrared, and so on. All right, if those are good enough, then there's no need to aim for long range because by overqueuing the application, very often you will be spending more money on more expensive devices. Connectivity, you have already learned, all right? Just for example, like Modbus, you have learned that you have RS485 to support the wired type. In terms of wirelessly, we have Modbus TCP. And in terms of application for connectivity layer, again, it all depends. If you want to join the internet, you can use RJ45 Ethernet cable to be wired or to be wired onto your laptop, for example, or you can go with wirelessly. Bandwidth refers to your y-axis over here. All right, how fast you want it to go. If you require high bandwidth, all right, 5G. 5G, although it promises high bandwidth, but that linkage, all right, is often short. Fortunately, all the telcos are willing to plan or at least put all the 5G gateway in close proximity, so that anywhere you go, you would have a 5G gateway near you, so that you stay connected to the internet. But 5G may not be cheap. So if you're looking at application, do pay attention. Do you really need that high bandwidth? Power consumption, right? Here you will see that there are high, moderate, and low, and there's nil. Nil means it is passive. What are passive? Like your QR code, right? It doesn't consume any power, but any other active communication will definitely require some power. The lowest of all so far would be Bluetooth, Zigbee, and Sigfox. 4G is one of the energy hungry protocol. It uses one of the highest, followed by Wi-Fi. In terms of mobility, all right, whether you can move around, of course, when we talk about mobility, we have to look at the whether it's wired or wireless. So when mobility is to be considered, then we are looking at this range, mainly for the wireless application, right? How far you want your wireless devices to be placed. If it's not to be too far away, then maybe you have a lot more option over here, right? But if you need long range, then these are the few that you can think about. Last but not least, in terms of cost, I think some of the hidden costs that you might not be aware would be the subscription cost, right? Some of the application, for example, 4G, which we all know, is on subscription basis, monthly subscription, either it's postpaid or prepaid. In terms of Sigfox, I think for now, Sigfox, they are free for now. If you have your own gateway supported, if you're asking for anyone to provide a gateway, maybe you have to pay for a fee. Therefore, in terms of cost, you have to be mindful. There are two parts. One part is on hardware, which is the infrastructure that you need to invest. The other side of the cost, which is on the soft side, which is the subscription cost. So you have to be mindful whether the subscription cost is going to be maintained at a flat rate or it's going to be volatile. It may change like stock price. Then you have to be very mindful. Once you invest in the infrastructure, and when the subscription cost were to get up, you might be in the losing end because you have paid so much for the infrastructure, and you might be having to pay more in terms of the subscription over a longer period of time. Therefore, these are the few considerations or parameters that you need to consider before selecting the option for connectivity layer.